Hello and welcome to the second installment of our school pack presentations about the moon. And in this presentation we're going to take a close look at eclipses, one of the most fascinating natural phenomenons that you can observe. Now, a very important message to make sure that everyone understands this is that we're going to be talking about the sun a lot in this talk, and it's important that you never ever look at the sun directly with the naked eye, and very much not through a telescope either. Never ever look directly at the sun without proper eye protection, because the sun can permanently damage your eyes. So you should only use approved eye protection when looking at the sun. This is very important, and I'll probably repeat this again at the end of the talk, so please do remember that. Now, onto the eclipses. So basically there are two types of eclipses. We have the situation where you have the sun and the earth, and the moon is between the sun and the earth, and we know from our first lecture that that means we have a new moon, or the moon is dark in the sky. And under certain circumstances, the moon can get in the way of the sunlight and create darkness in a certain location on Earth where the sunlight is being blocked. So that's known as a solar eclipse. The second type of eclipse is when the Earth is between the sun and the moon. And again, as we know from the previous talk, this will give us a full moon, so the moon is a full bright disk in the sky. And on certain occasions, the Earth can block sunlight from the moon, block sunlight from the sun to the moon, and this can cause the moon to darken, and this is known as a lunar eclipse. And so these are the two types of eclipses we're going to discuss today. There's another set of strange words that we need to be familiar with in order to describe eclipses, and that is umbra and penumbra. Now, if you were to take a large light and you put an object that can block the light some distance away from it, and you were to shine the light on that object, and you looked at a distance at what kind of shadow was on the wall, you would get a light shadow on the outside, which we call the penumbra. And this is light because some of the light from the large light source can get through because it's shining from all different directions. So the ball can only block certain amounts of light. So some light that can come up or shine down from certain directions isn't blocked, but other parts of the light is. But there is a section where all the light is blocked, and that's what we call the umbra, and that's the dark part. That's the darkest part of the shadow. So we will see this affect the penumbra and the umbra when we're talking about the sun, the earth, and the moon. So the first eclipse that we're going to, or type of eclipse we're going to look at, is the solar eclipse. Now, the thing about the sun and the moon is that even though they appear the same size to us from the sky, we know that the sun's diameter is 400 times larger than the moon, so wider, we'll say, than the moon. So the sun is phenomenally larger than the moon. They're not the same size. However, by pure coincidence, the moon is 400 times closer to us than the sun. So when you combine those two facts of something being 400 times wider but 400 times further away, we get the effect that from Earth they look like they're the same size. So it's a simple coincidence, and this very simple coincidence gives us this beautiful effect of the solar eclipse, so that the moon is just large enough to block out the sunlight, but small enough to allow us to see what is known as the solar corona. That's the sun's atmosphere, which glows brightly, but when the sun is unblocked, when the main sun is shining at us, it's too bright and we can't see the corona. So the moon is just perfect. It's the Goldilocks spot. It's not too big and not too small. It's just right. So therefore, there's no reason why we would have a solar eclipse like that, but we're very lucky. And in fact, in the entire solar system, on Earth is the only place where you can naturally see the solar corona from time to time, because no other planet's moon will match the size of the sun when viewed from that planet. Right, so let's look at the shadow that's cast by the solar eclipse. Now, we saw with the big light and the football in front of it that we had an umbra and penumbra effect. So we get the same effect when we have the light of the sun being blocked by the moon and the shadow being cast on the earth. And what happens is that we get the full shadow where the moon is right in front of the entire sun and blocks it out fully. And this is where you get the umbra. But then you'll get places where you have a penumbra. It's a lighter shadow. And from those places, when you look up, the sun isn't fully blocked. The moon is only partially covering the sun. And the further away from the umbra zone that you get, less and less of the sun is covered by the moon. So the full solar eclipse can only be seen when you're in that small zone of the solar, for the full solar eclipse of the umbra shadow. But of course, as we see later, it isn't a static shadow. As the whole system moves and the moon moves across the sun, that shadow will move across the earth. Now, the path of the eclipse. So if we look at the solar eclipse, full solar eclipse from August the 11th, 1999. Now, the reason I picked this one is that this is the first ever eclipse I had the great opportunity to see. And it's the closest total solar eclipse that to Ireland in 100 years, and it will be a long time before there'll be one so close or near Ireland again. Now, we'll see that this is obviously a map of Europe and Ireland and the UK. And if we trace across it this black strip, now this is the path that umbra shadow, that round, roughly round, it isn't exactly round because the earth isn't quite smooth and the perimeter of the moon isn't smooth, but it's more or less a circle. And as the moon moves across the face of the sun, the earth's, or the shadow of the full solar eclipse moves along the earth. So it means that people, anyone standing in that path, when that circle passes over them, what they see is the sun totally blocked out by the moon. And it's a beautiful, magnificent sight. And you can see there that the tip of the UK down near Cornwall was right in the path. And that's where I was lucky enough to see the solar eclipse. Now, outside of the zone of total eclipse, you get the zone of partial eclipse. So effectively what happens is that in the path you will see at maximum eclipse, the sun is completely covered by the moon. But anywhere outside it, the maximum eclipse you will see is only a partial covering of the sun. And as you can see, the further you move away from that zone of total eclipse, the less and less of the sun is seen. And if you look again at the globe there and you see that grey shadow, once you're outside the grey shadow, you don't see any of the eclipse at all. It makes no difference. And one of the amazing things is that you would think that the nearer you got to the path of the solar eclipse during maximum eclipse, the maximum solar eclipse, it would get darker and darker and darker and very dark. The magical thing about being in the path of a total solar eclipse is that even with only a few % of the sun being exposed behind the moon, it's at best a dull day. If you weren't looking up, if you weren't paying attention, it would just be like a cloudy day. It wouldn't be, you know, exceptionally dark. But as soon as the sun is cut out, as soon as the moon moves right in front of it, It's like switching off the light and it goes very, very dark. So anywhere where you have a zone of partial eclipse, it never gets very dark. Okay, so we talked in the last presentation that the distance between the Earth and the Moon isn't always the same because the Moon travels in an ellipse around the Earth rather than a circular path. So sometimes the Moon is a little bit further away from the Earth. And therefore, from the Earth, as we saw, it will appear about 14% bigger when it's nearer compared to its furthest away point. Now, this means that if the sun is at its furthest point from us, the perihelion, when it's at a new moon, it means that it's just slightly too small to cover the entire sun. So we need the moon to be closer to us to get the total solar eclipse. And if it's too far away, we get what's known as the annular solar eclipse. Annular from the Latin of ring. So the sun looks like a ring in the sky. And if we look at a map of the world here, now these are the paths of the solar eclipse, maximum solar eclipses that have occurred since the year 2000. And the paths in red are the annular eclipses, and the paths in blue are the total solar eclipses. And as you can see there, the blue lines, because 2/3 of the Earth is water, most of the solar eclipses will actually appear across the sea. And if you look at land, that's over 20 years. It's a very rare occurrence that a total solar eclipse will cross over an appreciable amount of land. So therefore, it's not that often that you get the opportunity to see a total solar eclipse. Now, the eclipse that I saw first in 1999 isn't on this map because obviously it's before the year 2000. So this is to show you that it's a rare occurrence for you to see a solar eclipse, and if you do get the opportunity, you really should take it. It's a magnificent sight. The land goes dark, animals go quiet because they think it's night, and it's like dawn all around the horizon. It's a beautiful thing to see. Now, the next solar eclipse viewable from Ireland is actually on June 10th, 2021. Now, it's an annular eclipse, so it isn't a total eclipse. And also, we're only in the partial eclipse zone. So what we will see on June 10th is at about 10 o'clock, the moon will start to cross over onto the face of the sun. The maximum that we'll see will occur at around 5 minutes past 11. As you can see here, it's far from a total solar eclipse. We're quite a bit away from the path of it. So less than a quarter of the sun's face will be covered. And the moon will move out of the face of the sun by about 12:18. But still, it's an impressive thing to see. And the activity sheet in the school pack for eclipses shows you a design on how to make a pinhole camera, which is a very simple device to allow you to look at the shadow of the sun or the reflection of the sun and see the shadow of the moon cross it safely without looking directly at the sun. So be sure to download those instructions and try and make your own pinhole camera. And here we actually see the path of this particular annular eclipse. And as you can see, the maximum annular, where they'll see the ring of the sun, where the moon passes right in front of the face of the moon, or sorry, the moon passes right in front of the face of the sun, is up in northern Canada and Greenland. So we're quite a bit away from the path of totality, or at least the path of the maximum annular. Now, the next total solar eclipse, where we will see the full total solar eclipse in Ireland, is not till the 23rd of September 2090. I'm not too sure how many people watching this now will be around then. I mean, we're talking over 70 years away, but maybe some of you will be around, and if you are, be sure to look up on the 23rd of September 2090. I hope you enjoy it because I have a feeling I won't be there. Okay, so the next type of eclipse is a lunar eclipse. Now, as I said, a lunar eclipse is when the shadow of the Earth is cast onto the moon, as opposed to the shadow of the moon being cast onto the Earth. Now, in this instance, now the shadow is far larger than the surface we're looking at, because as we saw in a solar eclipse, the shadow cast was very small compared to the size of the Earth. So only some people on Earth could see the solar eclipse. But in the case of a lunar eclipse, the entire moon will be covered in the shadow if it's a total lunar eclipse. So anyone on Earth that is on the side of the Earth that can see the moon will see the eclipse. So much more people can see a lunar eclipse. So therefore, it's a much more frequent occurrence. Now, the diagram here, as I said, is not to scale. If you look at the first presentation, you'll get an idea of what the distance between the Earth and the Moon is to scale and the Sun. So this is just to show you the shadows. Now, if we look at the shadow here, if there was a huge screen up in space, and we put it if we put it on the night side of the Earth, shall we say, you would see a grey shadow, and then in the middle you would see a dark shadow. So this is the Umbra and the Penumbra. And if you were floating out in space, if you were in the Umbra, you wouldn't be able to see the sun because the Earth is blocking it out. And if you were in the Penumbra, you'd see a part of the sun's face with the Earth partially blocking it out. So that's the shadow that's cast into space. Now, in a lunar eclipse, what happens is that normally a moon, and the moon, and we'll look at this a little bit later on as to why this happens. Normally the moon will pass below or above the penumbra shadow, so it never passes through the shadow most of the time. Now, but sometimes it passes right through the umbra shadow, and that's when we get a lunar eclipse. And the moon becomes very dark. In fact, it looks red, and we'll look at the reason why it might be a red color in a minute. You can also get what we call a penumbral eclipse, and that's when the moon just passes through the penumbral part of the shadow. It's less dramatic, but the moon can be seen to darken at the same time. So these are the types of lunar eclipses that we get. Now, the next full lunar eclipse is viewable from Ireland on May 16th, 2022. So not for a few years, and but you will see the moon will pass into the penumbral shadow first at about 1:30 in the morning. So if you want to see this lunar eclipse, you've got to be prepared either to stay up late or get up very, very early. By about 2:30, it will start entering the umbral part of the shadow. And by 3:30, it'll be fully in the umbral shadow, and it'll be this red color, and it'll be right in the middle of it at about 11 minutes past 4. It'll start leaving the total eclipse, shall we say, starts ending because it's leaving the umbral shadow nearly at about 5 o'clock, and the partial eclipse ends at 5:05, and the total eclipse ends, and we call it a partial eclipse when it's in the penumbral. The penumbral eclipse will end at 10:07. Now, as it happens, the moon sets in Ireland on that day at 5:20 in the morning. So we won't see the end of the partial eclipse and it leaving the penumbral eclipse, but you will see all the other events. So it's something to put in the diary if you're someone who plans well ahead. Now, why does the eclipsed moon look red? So some of the photographs that I showed you showed the moon being a reddish color when it's in the Earth's shadow. Well, the reason is this. So as you will have learned in science, the light that comes from the sun is actually made up of a load of different colors, and all these colors have a different wavelength, but when they all combine, they look like a bright white color. But light can get deflected. That is to say, we can split out all these combined lights under special circumstances, as can happen, for instance, when there's a lot of water in the atmosphere. On a sunny day when you get a lot of rain, you see that the sunlight is split and we get this, what we call a rainbow. So this is how a rainbow is made, is that the light that's normally all combined together to make white light is split out into its separate colors. Now, the light can also be split if it hits the Earth's atmosphere. Now, so the sunlight that comes through the Earth's atmosphere, that will bend out the light as well. Now, the red light is the longest wavelength, so it gets bent the most. So a lot of red wave light kind of gets bent around the Earth. So instead of being blocked into the shadow, it bends into the shadow. So the other light is blocked, but the red gets through. So that's why the moon kind of looks like a reddish disk in a full lunar eclipse. So a lunar eclipse will prove to you that light is made up of many colors, and that red light is the longest wavelength because it's bent most in the atmosphere. So it's a lovely experiment to see nature performing. And this is the kind of image you will get. Hopefully it'll be a lovely clear night that's not blocked by clouds, which unfortunately happens too often in Ireland. Now, from my last talk, when I said that every month the Earth passes between, the moon passes between the Earth and the Sun, and that's when we have a new moon. And then when the Earth is between the moon and the Sun, we get a full moon. So why don't we get an eclipse, a solar eclipse and a lunar eclipse every month if they're getting in each other's way every month? They're not quite. And the reason is this. This depicts, and again, it's not to scale, but this is the Earth's orbit around the Sun. Now, there's another phrase that we use, and we call it the orbital plane. And what the orbital plane is basically is that if you could imagine a plane, a two-dimensional plane, and the perimeter of the plane is the orbit. So this is like a disk around the Sun, and the Earth travels around the edge of that disk. Now, if we look at the orbit of the moon, and this is the orbit of the moon around the Earth. And if we look at its orbital plane is actually at an angle to the Earth's orbital plane, to the Sun, which means that when we look at it from the edge, we can see that there are times when, even though the moon, when seen from above, is between the Earth and the Sun, it's actually above the line between the Earth and the Sun. And sometimes it can be below the line. So just because when we show a depiction of the Earth being between the Sun and the Earth, it doesn't mean it's directly between them. And when it isn't directly between them, we don't get an eclipse. So, and this angle is about 5 degrees. So here we can see that just because the Earth is between the Sun and the Moon, or the Moon is between the Sun and the Earth, we don't necessarily get the eclipses. Because as you can see here, the shadow of the Moon is not falling on the Earth because it's above the line between the Earth and the Sun. And likewise then, the Earth, the shadow of the Earth is going above the Moon, because the Moon is actually, even though the Earth is between the Sun and the Moon is actually below the line. So this is an unfavorable situation for an eclipse, and it happens, usually, most cases are unfavorable, because the line that connects the Sun, Moon and Earth, or the Moon, Earth and Sun, is not a straight line. So the shadows miss. But it can happen on occasions when the Moon is at that point in its orbit where the orbital plane of the Moon intersects the orbital plane of the Sun, of the Earth going around the Sun. And just at that point, so if it just happens that we have a full moon and the Moon is at that intersection point, then we will get situations which are favorable for an eclipse, because on these rare occasions, the sun, the moon, and the earth are in an exact straight line. And so that's when we will get solar eclipses and lunar eclipses. Now, here we have the list of solar eclipses and lunar eclipses over the next 10 years or so. And you can see here that they kind of, the solar eclipses happen in patterns, and lunar eclipses roughly as well, where you can get two in a year, and then it'll miss a year or two, and then another two. And that's basically because the Earth's orbital plane and the moon's orbital plane have to be just synchronized with the full moon and the new moon for there to be eclipses, as we had said. And when this happens, they're synchronized on a number of occasions before they go out of sync again. And therefore, you'll get maybe two in 1 year, none for a year, and then two another year. And we can see here that there are a number of interesting eclipses that come relatively close to Europe and Ireland, especially number 8 there, which happens in 2026. There'll be a beautiful full solar eclipse. So if you go to northern Spain, you'll get to see that. And in 2023, there is, and 2024, there are eclipses which cross the main part of North America as well. So as you can see, it's a rare event, and you really, really should go and see these phenomena when you can. Finally, you've seen the slide before, but it's worth saying again. Please, when you want to observe the sun, never, ever, ever look directly at the sun without proper eye protection, because the sun can permanently damage your eyes. Something you may not know, which I'm sure you will learn in school, is that the back of your eye is clustered with light sensors and a big optical nerve. And there's no pain nerves in the back of your eye. So if the sun light is concentrated in the back of your eye and it starts to burn the back of your eye, you won't feel it. So you can damage your eye without even knowing it. So please, never ever look at the sun directly. Only use approved eye protection, or you can use the activity sheet that you can download from themoon.ie in this edition of the school pack. I hope you enjoyed this edition. If you have any comments, any questions, please don't hesitate in contacting me. So until the next time, I wish you clear skies.